Hi everyone, welcome back to our channel where we make chemistry easy and fun. Today we're going to dive into the world of salts. You've probably heard of table salt, but did you know there are many different types of salts in chemistry? In this video we'll explore what salts are, the difference between normal salts and acid salts, anhydrous and hydrated salts, as well as soluble and insoluble salts. Finally, we'll discuss some common uses of salts and also discuss the potential dangers associated with them. Let's get started. First, what exactly is a salt? In chemistry, a salt is an ionic compound formed when the hydrogen ions of an acid get replaced by metal ions or ammonium ions. This can occur when the acid reacts with a base, a reactive metal, or a metal carbonate or hydrogen carbonate. For example, when hydrochloric acid reacts with sodium hydroxide, the hydrogen ion from the acid is replaced by a sodium ion from the base, forming sodium chloride, which is common table salt used in cooking, food preservation, and manufacture of soaps. When magnesium is added to sulfuric acid, the hydrogen ions from the acid are replaced by magnesium ions from the metal, forming magnesium sulfate, also known as Epsom salt, used as a bath salt, laxative, and beauty product. Now let's talk about the difference between normal salts and acid salts. A normal salt is formed when all the hydrogen ions from the acid are completely replaced by metal ions or ammonium ions. For example, sodium chloride and potassium sulfate are normal salts. Notice that the hydrogen ions from the original acid are all gone, and only the metal ions are present as the cation ions in the salt. Note the proportion of base to acid in the reaction to form potassium sulfate, which is 2:1. On the other hand, an acid salt is formed when only some of the hydrogen ions are replaced, meaning the salt still contains replaceable hydrogen ions. Acid salts typically form from polybasic acids, which have more than one hydrogen ion that can be replaced. A common example is sodium hydrogen sulfate, where only one of the hydrogen ions in sulfuric acid is replaced. We can also write an equation to represent the formation of this acid salt. Notice that the proportion of base to acid is different in this reaction. The base and acid react in a 1:1 ratio in forming the acid salt. Next, let's explore the difference between anhydrous salts and hydrated salts. An anhydrous salt is one that does not contain any water molecules within its crystal structure. These salts are often formed by simple direct combination reactions in the absence of water or by heating hydrated salts to remove the water. They tend to have a dull, powdery appearance. For example, anhydrous copper 2-sulfate, CuSO4, is a white powder. Hydrated salts, on the other hand, contain water molecules within their crystal structure. These water molecules are called water of crystallization. This usually gives the salt a shiny, crystalline appearance and sometimes contribute to them appearing colored. A classic example is hydrated copper 2-sulfate, CuSO4.5H2O, which is blue due to the presence of water. Heating hydrated copper 2-sulfate will remove the water, turning it into its anhydrous form. It changes from blue crystals to a white powder as the water of crystallization is removed. Next, let's talk about soluble and insoluble salts. Soluble salts are those that dissolve in water to form a solution. Common examples include sodium chloride, NaCl, and potassium nitrate, KNO3. These salts readily dissolve in water, making them useful in various applications. One helpful rule you should remember is that all salts of group 1 metals like sodium and potassium and all ammonium salts are soluble. Insoluble salts, however, do not dissolve in water. An example is calcium carbonate, CaCO3, which is found in chalk, limestone, and marble. When you add calcium carbonate to water, it remains as a solid and doesn't dissolve, forming a suspension. Now, let's take a look at the various uses of salts, starting with the action of baking powder and the role of calcium carbonate in the manufacture of cement. Baking powder is a key ingredient in baking. It's a mixture of sodium bicarbonate and an acid, often cream of tartar. When baking powder is mixed with water, it releases carbon dioxide gas, which helps dough rise by creating bubbles in the mixture. Calcium carbonate, CaCO3, is essential in the manufacture of cement. When heated, calcium carbonate breaks down to form calcium oxide, CaO, and carbon dioxide, CO2. The calcium oxide is then mixed with water and other materials to form cement, which hardens over time to create strong, durable structures. Salts also play a crucial role in food preservation, helping to keep food safe and extend its shelf life. Some common salts used in food preservation include sodium chloride, sodium nitrite, and sodium benzoate. Sodium chloride, or table salt, is the most common preservative. It works by drawing moisture out of food, which inhibits the growth of bacteria. Sodium nitrite and sodium nitrate are used to preserve meats, giving them a distinctive pink color and preventing the growth of harmful bacteria like Clostridium botulinum. Sodium benzoate is another preservative used in acidic foods like salad dressings, sodas, and jams to prevent mold and bacterial growth. Salts are also widely used in the medical field. Two examples include plaster of Paris and Epsom salts. Plaster of Paris, made from calcium sulfate, CaSO4, is used to create casts that immobilize broken bones. When mixed with water, it forms a thick paste that hardens quickly, providing support to the injured area. Epsom salts, or magnesium sulfate, MgSO4, are often used in baths to relieve muscle pain and reduce inflammation. The magnesium in Epsom salts can be absorbed through the skin, promoting relaxation and recovery. While salts are incredibly useful, they can also pose dangers, especially when used improperly or in excess. One salt of particular concern is sodium nitrate. Sodium nitrate is commonly used in processed meats like bacon, ham, and hot dogs to prevent bacterial growth and preserve color. However, sodium nitrate has been implicated in causing brain damage in infants and is also suspected to be carcinogenic, meaning it could increase the risk of cancer. Due to these risks, it's important to be aware of how much sodium nitrate you're consuming and to consider alternatives whenever possible. So there you have it. We've covered what salts are, the differences between normal salts and acid salts, anhydrous salts and hydrated salts, and soluble salts versus insoluble salts. Understanding these differences is key to mastering the topic of salts in chemistry. Additionally, while salts are essential in food preservation, construction, and medicine, it's important to use them responsibly and be mindful of the risks. If you found this video helpful, make sure to give it a thumbs up, leave a comment if you have any questions, and don't forget to subscribe to our channel for more chemistry lessons. Thanks for watching, and keep exploring the wonders of science.